Hey class, so here's a video on problem 62 from the homework. As we look at this, let's observe what the problem gives us and what we're asked for. So the things that are given to us in the problem statement is we're told what the mass of the block is, we're told what the spring constant K is, and we're also told what the distance it compresses down is. I'll give that the variable d for now. And then what we want, or what we're asked for, in part A, we're asked to determine what the work done is by gravity. In part B, we're asked to determine what the work is done by the spring. And then in part C, that's my dog playing with his toy. And then in part C, we're asked to determine what the what the initial velocity of the block was before contacting the spring. And we can observe from the problem statement, we can also consider the final velocity to be given as 0 meters per second, since we know it comes to rest when it's at its maximum displacement. So in considering this problem, really what we're considering is the work energy theorem, which tells us that the net work acting on the object here during this displacement is going to be equal to its change in kinetic energy. So what that means is that the work done by gravity, my dog really wants to play, plus the work done by the spring is going to be equal to the change in kinetic energy, which is 1/2 mv final squared minus the 1/2 mv initial squared. So, if we can find our different works, then we should be able to solve for that initial velocity that we're asked for in part C, because we know the final velocity is 0. So the work done by gravity that we're asked for in part A, we know to be equal to mg times your h initial minus your h final. And in this case, the work done by gravity is going to be equal to mg times d, which is our distance that it moves down, starting above where it ends, so we get a positive gravitational work. Part B, on the other hand, is the work done by the spring, which we learned in class is equal to 1/2 k x initial squared minus 1/2 k x final squared. And so this is where it gets a little bit tricky, because your initial displacement is 0. It's not distorted at all. The final displacement, that is your variable d that we're given. So as you can see, we have a negative work for our spring and a positive work done by gravity. So what you should be able to do then is you take your work done by the spring, plug it in up here, and your work done by gravity, and plug it in up here, and solve for that initial velocity, and that should make doing part D possible as well. My dog is real excited that you guys are all learning so much physics right now. Anyway, that's it. Let me know if you have any additional questions, and other than that, have a box-worthy night.